Hello. Welcome to Kubernetes SIG Architecture Deep Dive. Just as a disclaimer, I was asked as last minute to present this original deck, and I kind of modified it quite a bit. So my hope is that this should be kind of an informal conversation. I want to know what it is that you want to know, right? So part of the Kubernetes community is getting feedback, right? So just to get us started, my name is Tim St. Clair. I am one of the co-leads for SIG Cluster Lifecycle. I work I'm a Conformance cat wrangler. I work as a sub-project sort of TL lead for SIG Architecture. I'm a steering committee member and a senior staff engineer at VMware. So what I really want to know is, why'd you come here? Like, what is it that you want to get out of understanding of SIG architecture? Feel free to ask. Like, raise your hand if you want to. If you have something that you want to get out of this talk, that you want to know more about the architecture of Kubernetes, it's your time. Go ahead.
I was wondering if there's a mic on there so everyone else in the recording can hear.
Sure.
Yeah, got to double check. So I want to understand what the process is that Kubernetes community goes through when it comes to architecting and designing things.
Okay.
So I know that there is a KEP, which is like a proposal for a feature. Mm-hmm. And how does SIG architecture tie in a lot with those KEPs and how they evolve into implementation?
Mm-hmm. Yeah, I'm going to cover some of that. I actually have bits of that in my slide deck. So are there other things that people want to know about? This is your conference, this is your time. So if you want to know things, if you want to understand it, I can go through like a broad overview, but if there's specific questions you want to ask, I really want to know what your feedback is. What is it you want to know about SIG Arch? Because it's like a Rorschach card. Like, the architecture of Kubernetes has many, many pieces. So I can go into different facets, but there's no way I could possibly cover all of it in a time span of like 30 minutes. So if there's particular aspects that you want to know, now's the time to ask. Or you can just feel free to interrupt along the way, and I'll pass the mic along too. Oh, didn't see it.
Thanks. So my question is, for sort of large overarching efforts like code cleanup and refactoring, mm-hmm. is that something that SIG architecture handles and plans?
Yep, that's also in the deck, so we will talk about that. So I at least got some of the bases covered here. So as I go along, if you have questions, just feel free to raise your hand. I'll be happy to answer them along the way. So I'll start out with a couple of main precepts, right? Kubernetes is like an engine. I view it as the fundamental layer that you can use to build higher order systems to solve user-facing problems, right? There's many pieces and moving parts, but just by a show of hands, how many people think Kubernetes is pretty complicated? Right? So that's the common theme you hear, right? But I like to demystify complexity by making it seem ridiculous, right? So I say Kubernetes is a toaster, right? And if you take a step back and you think about how a toaster works, and then also you apply that to the core concepts of Kubernetes, it demystifies it and makes it very simple to understand, and all of a sudden the patterns start to emerge over and over and over again. All right, so declarative versus imperative inside of the system. You declare a given state. I turn my toaster to light brown, right? I hit the button, and then I walk away for a while, and hopefully my house doesn't burn down. And my toast, when I come back, should be light brown. I've declared a state of what I want to do. I let the system, I flip a switch, or I submit my toast, right? Then I expect the system to rectify that loop, and then give me back what I expected, right? So that's kind of the basic concept behind almost all the core primitives inside of Kubernetes. It's just layer upon layer upon layer stacked of this basic concept, right? Another important piece here is a highly consistent key value store for storing what is the declared state that you want to achieve, right? And in order for you to have a declared state and also to figure out where you currently are, if it's not highly consistent, that's a bad feedback loop. Imagine if you had your toaster oven and you said you wanted light brown, and you didn't actually have temperature control. You could either burn your house down, or you could never have toast, right? So that highly consistent key value store is the way by which you can achieve that feedback signal coming back into your system over time. The way Kubernetes works is it's a very rudimentary feedback loop system. So if people understand control theory, or if you had like an electrical engineering background, a lot of people would think of things like PID controllers for doing fast feedback loops. Kubernetes is very rudimentary. It's 90% of the feedback loop system is proportional. So you're basically doing stepwise integration to achieve your state, right? Does that make sense? Yeah, okay. Questions? Everybody's good. So again, if you have bad feedback loops, and a part of the challenge of Kubernetes is finding that signal of where the bad feedback loops exist inside of the system, because there are some. Sometimes there's noise that resonates throughout the system. You can burn the house down. Now, over time, we've eliminated a lot of the common bad feedback loops in the system. Like Merrick and I have burned the house down 1 million times, right? So that was part of our old job. So we were meant to find where you could basically hit it too hard and the whole machine would just implode. So with that in mind, taking a step back of like, what is Kubernetes? Then seeing the broader picture of what are the pieces of the puzzle, what does SIG Arch do? What's the scope of SIG architecture? This is straight out of the charter. SIG architecture maintains and evolves design principles of Kubernetes, it's a very fancy way of saying it, that provides consistent body of expertise around conformance testing, API conventions, architectural renderings, design principles, and deprecation policy. So it's basically how do we evolve the system over time, right? Not only how do we evolve the system, but it's also, the conformance aspect is a little bit different, is that what are the expectations that we are trying to set on the system so that way it's consistent across the ecosystem of providers that could exist. So SIG architecture is primarily responsible for dealing with cross-cutting concerns. API reviews affect everybody. If you have a bad API, or that's a contract that you're going to have to support in perpetuity for several iterations if you make a mistake. So API review process affects everybody, right? A lot of times these APIs are also interwoven across components. Right? So like if you make a slight modification to a node specification, right, or an aspect of a given field of something, it might have to percolate through all the components, including the API server, the controller manager, the scheduler. Another cross-cutting concern is conformance test review and management. Trying to guarantee that the tests and the behavior of the tests actually verify consistency is a difficult thing at times. In part because some of the testing mechanisms that we currently had rely on behavior inside of the system that's not guaranteed, right? So we have to make sure that when we are vetting the end-to-end test suites that we are creating, it's relying upon the guaranteed contract that we are trying to uphold, right? There's a lot of little pieces, there's minutia inside the contract that we don't support. So for example, we don't guarantee that the error messages are consistent, right? So if you you cannot like try to enumerate your error state space and expect to have consistent errors over time. That's not a contract that we uphold, right? We don't uphold conditions either. So there's condition messages that occur inside of the system. We don't uphold that as consistent over time either. Another important aspect is we also try to revise and modify and have input into sort of the design process, or KEPs. How many people have heard of KEPs? That's fairly decent. So those are Kubernetes enhancement proposals. When the whole system, if you're going to change an API, if you want to have something that's a cross-cutting feature, such as like making a node modification that percolates into the controller or the scheduler, those things require a KEP. Like SIG architecture will be the stopgap review for anything that cuts across those boundary lines. And it is required to have a KEP in place. Usually the process by which KEPs are reviewed is if it's mostly underneath a given subgroup, that SIG chair or SIG TLs will review that individual KEP and try to flush it out at that level first. but then we'll recognize that this cuts across. In that case, then it has to be approved by SIG Arch. Go ahead.
Onto KEPs and writing KEPs. So one thing that I've heard a lot about at this conference is there's a lot of people who are, there's quite a few people out there who are new to Kubernetes, or they want to contribute and they want to do a KEP. What support and resources are there out there for people who want to write a KEP? Like, what would you suggest for if someone's new to the community and they perhaps want to write a KEP? Yeah.
So the first thing you usually start before you even write the KEP is you have an idea for a feature, right? So there's a certain aspect of Kubernetes that's missing, or something I want to change. So typically you'd start with your individual SIG that you're a contributor on, right? And you discuss that with the TL to even see if there's time to try and fit that into this cycle or next cycle, right? And usually what the TL will do is work with you to figure out what are the boundary lines for a KEP for the feature that you're trying to ask. The most important thing that I look for in KEPs is not necessarily what the individual goals are, but I also really, really look for what are the non-goals that you're trying to achieve. Because proposals can sometimes be way too open-ended. And it's very difficult to make sure that you put the sort of the legal mind hat on to sort of say, where does this stop, right? So long as your Lego brick for your feature enhancement is bounded, then if that passes that first part, then you start to work with a KEP with the TL with the individual SIG that you're working with, and then bump it up once it's been reviewed within that SIG up to SIG architecture. So you would work closely with the TL/chair. You can also work with the PM group and SIG architecture itself too. So there's many channels. Usually I'd say try to start with your SIG first and that chair and that TL, and they'll be there to help you. Because everything inside of the Kubernetes ecosystem is a servant set of leadership. If you are in a leadership position, your goal is to help facilitate. It is not necessarily to rule with an iron fist or try to control the code, right?
Thank you.
Yep. And deprecation policy, I already mentioned that. So what are some cross-cutting concerns? There are a lot of SIGs, working groups, and other aspects to Kubernetes. It is the second largest project on GitHub. So if you are looking at a Kubernetes org chart, this is probably the best example of what exists currently today. So there are several user groups. There's only one noted here. There are many working groups. Working groups are meant to be ephemeral, but over time we found that some of these concepts are pretty complicated, so they hang around for quite some time. And there are several SIGs. It is our goal within SIG architecture and as well as steering to kind of collapse some of these under larger umbrellas. So one of the things that you're seeing now too is the collapsing of SIGs under larger umbrella SIGs. So like cloud provider is a great example of that. So SIG architecture is like the stopgap to help evaluate things that cut across this entire org chart. What are some other kinds of issues that aren't mentioned before? Ambiguous behavioral questions, right? There's a lot of concepts in Kubernetes, right? The core primitives, the core ideas behind there are actually only about less than a dozen, but there are a lot of things built around it, right? A corpus of things that are built on top of those core concepts. So ambiguous behaviors for APIs is a good example, right? So one API might behave a certain way, and then another one might behave a different way. A good example of this is storage. Storage has a very unique API that behaves slightly differently than a lot of the other APIs. So trying to match the patterns and talking with SIG architecture about like, we don't expect this, we want different behavior. Unanswered questions, there's a lot of them. If you look inside of the code structure, for example, you will be left with more questions than answers because it's a constant work in progress, right? There was ideas of trying to get to a grand vision of a unified field theory of where we wanted to be, but then practicality of trying to get there became very, very difficult, right? So we kind of are in this way station of how the code is currently structured. Now there's a lot of work to do, like for example for code structure, but it's not by any means complete, and help is wanted. Anytime there are conflicts across chairs, right? And this happens quite a lot. You know, open source, come for the code, stay for the drama, right? So sometimes when you go and a person really wants to promote a feature, right? For example, getting Windows to GA. Me personally, I pushed back very, very hard against that. But ultimately I lost, right? I lost for one cycle. I won for several before that. Because we want to make sure that the features we are producing have a cut across the project to be able to support those features, right? So, and sometimes the answers are not complete. We have to sort of be okay, like perfect is the enemy of the good. We have to be okay with the idea of being able to produce a feature for this time period to get feedback and then refine that over time. And always, like I mentioned before, if you want to come before SIG Architecture, you must have a KEP pretty much to be able to have a conversation. SIG Architecture nowadays is basically a federated group of subprojects. That is the common pattern that's existing now and kind of coming up across the entire organizational org chart that I showed earlier. So the main SIG Architecture group basically federates out most of its work items to these individual subprojects. There's an architecture and API review group. That particular subproject's led by Jordan Liggett, where he goes through and will review individual APIs. And it's a very exhaustive process. Then there's a code organization subproject that's run by DIMS. And that is very open-ended and kind of subjective, right? There are objective pieces that you could probably say are non-controversial, and there are ones that are taste and style, right? If you're looking at Kubernetes as a idiomatic style of Go way to structure your repository, you are looking in the wrong place. Kubernetes is a very, very large project and stretches the boundaries of what most people had even expected. So as a result, there are weird idiosyncrasies, and what would be helpful from the community is if you have like experience across many different projects, and you've dealt with this before in other projects, is to feed back in that signal, right? What we don't want to have happen is a lot of us old-timers that have been in the project since the very beginning is we have our own language. Like we talk to each other and we know how to converse at sort of a very high bandwidth level that allows us to move back and forth, but that's a little echo chamber, right? And we don't want that echo chamber. Like we need a diverse set of opinions from a diverse group of people to make sure that we are doing right by the people in the community, right? Because if a person comes to the project and they're just in shock and awe when they first come there, that's not helpful, right? We want to be able to on-ramp individuals to say, like, you can start here first, and then this makes it easier second. So ideally, we want to get to the point where we have a very smooth, clean transition of not only how can you get onto the project, how can you understand things, this is how the code is structured, this is how things flow, here are the APIs, how the APIs kind of roll, and it's a total work in progress, and we need your help. Last but not least is the conformance definition and review process. That's the subproject that I lead and work on. In that subproject, we spend a lot of time going through the existing test suite, which has a corpus of thousands and thousands of tests right now, and trying to vet them and get them into a good enough state so that they can be consumed by the entire community. So when you stand up a cluster in the wild, or whether it be on GKE, EKS, AKS, by yourself, the hard way, whatever, you should always run the conformance test suite against your cluster to guarantee that what you are running meets a certain criteria or set of expectations. If it does not pass a conformance test suite, it is not officially sealed and stamped by Kubernetes. And there are a lot out there, right? So if you are using a hosted service offering from XYZ, you should run the suite and verify and talk to your provider to make sure that the contract that we uphold or the API behavior that we expect will actually be matched by what you're using. Because the promise of Kubernetes, the whole purpose at its fundamental level is to be the abstraction layer that you can write across different providers and different clouds, right? If that abstraction layer doesn't hold true and we develop balkanization, the promise of Kubernetes is lost, right? So that's super important. Ideally, over time, we want to raise all boats. If Kubernetes is ubiquitous and everywhere, we have the ability to just work seamlessly across cloud providers, right? So I didn't want to go into too much of some of this, so there are links inside the slide deck that I posted online. API review has a well-defined process. There's no way I can possibly go through all the details of what an API review is in this deck. But what I do want to let you know is that if you go to the Kubernetes project, there is a project board that exists. So if you are ever, oopsies. If you are in the Kubernetes project and you want to see, or if you want to actually promote something, the bots are being modified currently to say /project, and then you say which project subproject you are working on. That will get you on the project review board in order for you to actually be able to get eyeballs on what you are working on. The Kubernetes project is so large, if you just submit a rando PR, odds are it will not be seen. There's just way too much. Currently there's like several thousand open PRs there's 1,000 open PRs and several thousand open issues, right? And there's about a group of 4 API reviewers, right? So 4 or 5 that are very active. Jordan's the most active. He's really like the standard bearer dealing with 90% of the API reviews. And if you think about that, that doesn't really scale. So we need automation, and again, we need your help. So we have a bunch of documentation. So if you are super interested in API structure and how APIs work, I highly recommend reading the document that's listed here and going and shadowing an API reviewer, right? You will find it is very illuminating to understand how the system works. And if you just want to know more about it, that's a good process to go along with it. And there also are recordings that already exist. So, you don't necessarily always have to shadow because, some of those people are super busy. If you're serious about it, you should. But if you just want to see the process, there are recordings that exist up on YouTube today that actually walk through the process in totality. Next, the conformance and test promotion. Again, we have a project board just like the other one. Currently, our project board that we are working on is a lot busier. There are several things that are currently in flight. There's a lot of things inbound, things are ongoing. If you are new to the project and you want to get involved from the outside in, this is an excellent way to get engaged. You're looking at it from an external behavioral perspective, right? And you're trying to guarantee or qualify the APIs that currently exist. So doing that, sometimes when you work from the outside in, it's a very good way to understand how the system works and functions. And sometimes you will be surprised by what you learn. Like, oh, I didn't know that happened. That happens to me. I mean, I work on the project since the very, very beginning, and I'm always intrigued every now and then to be like, oh, that's new, didn't know that. Or the knowledge that I had originally is now no longer applies. So what I thought worked X, Y, Z years ago, now when I test it out is not the same as it was, right? So working from this type of mindset, going from the outside in, helping the conformance effort, is very helpful to the project. And it's a great way to learn. Code organization. This is subjective. It's highly subjective. People are very opinionated too. But there are long-standing opinions there are known knowns, there are unknown unknowns. The known knowns is there's a lot of current work that already exists that people that need help, right? A lot of the code restructuring is not easy. It's Go. Go does not deal well with like shifting stuff around. Like you're gonna have to update every file, right? So those type of modifications require help. So there's some other ones that require more heavy lifting, right? In the ideal world, in the fullness of time, Kubernetes is a set of repositories and not a monorepo, right? That's the ideal thing that we always tried to aim for, but it's kind of stopped, right? It stopped in part because APIs are not V1, right? If we can get all the APIs to a well-defined, stable state, we could federate out repositories a lot cleaner because we would have so much churn. But think about what happens every time I change an API. The code is structured in a document view model. So if you follow old patterns, if you're like super old like me and you've read idioms before patterns even existed, and then you read patterns, and then all patterns don't apply because you can get around it with compiler tricks, then you realize that it's a document view. And with a document view, that means your dependencies exist all over your code. And the API is the contract. So if you want to be able to restructure something, if you want to move your code around, if you want to change some very simple primitives, all of a sudden those things percolate and cut across the entire repository. The dependency graph is huge. So code restructuring for getting things out of the repository, like getting the componentry separated out, will only really happen once APIs are fully promoted to V1. Once they're in that stable state, they can be done in a different way. But there's a lot of other machinations that can occur along the way. Go module support is one of the things that people have been working on. And again, if you want to, there is a separate project board that you can take a look at, and they also have a current backlog in progress. DIMS is the lead of that. They have their own separate meeting. You can always attend that too if you're interested. So if you're very passionate about how code is laid out and structured, I highly recommend going to that one. So with all that in mind, SIG Architecture has broad goals. Like the larger group sees at a 50,000-foot view of the landscape, like where we ideally want to go with the project, right? In the fullness of time, we ideally want to lock down the core. The core should be less iterative than it currently is. So in order for us to do that, we need to promote API extension mechanisms and extension policies that exist inside the system. A lot of that exists today, but I wouldn't say it's fully mature, right? CRDs are still in beta. We need CRDs to be GA. But even after that, it's going to take some time before all of the feedback loop from the ecosystem comes back in to play so that we kind of harden things and modify things for CRDs, and as well as other extensions. What we'll probably see happen too over time, and I already see it today, it's highly opinionated, so I'll save my opinion till the end if people want to ask me what that opinion is that you see patterns that exist out in the ecosystem. Some of those patterns become fractal, and they're the same pattern that exists over and over, right? And those fractal patterns should really be distilled down into core concepts that exist inside of Kubernetes, because why reinvent the wheel 5 different times and make 5 different mistakes, right? It doesn't make sense to do that. As I mentioned before, we're still trying to build out conformance. We need help there. A lot of the effort that we see going into the future that we would like to see in the core Kubernetes repository is focus on reliability. We've gotten to a really good state, I think, at this point, as far as like maturity of the organization, but we still have a problem with reliability, in part because it's tough, right? This is a distributed system, and it requires a set of tests that go beyond the standard end-to-end tests. So how many people have ever installed a Kubernetes, 1.14, anything that has a .0 at the end? All right. Have you used it in production? You're crazy, man. So if you used a .0 in production, you are far braver than 90% of the people I know. If you use it in dev, this is kind of the model that we want to get to, is we want to get it to the idea where we sort of publish things as a .0 is a good dev release, right? And update your dev clusters. Installing a .0 in prod has the number of PRs that we get after we release Kubernetes release depends upon the cycle. It can be in the order of hundreds that we get shortly afterwards, because all of a sudden it gets in the wild and we find all the things that we were missing either in test coverage or like, oh, I didn't know, we never even expected that. And that happens all the time. But if you look over like a larger time span, like we have graphs of this, and like the 114 series currently has 500 PRs and get diff between that and the actual 114.0. So that's got to tell you that like reliability is important. Having people help to focus on reliability and testing and actually become beta testers for a lot of these things, and if they have your own test suite, which I know people that use it in prod do, you have your own qualification procedures for your next Kubernetes release. And if you don't, you should, because the .0 release is not guaranteed. Another thing that we're focusing on, and it's not just Kubernetes proper, it's not just the code itself, but organization scaling, right? As I mentioned before, like Jordan's one person, and he's almost superhuman, but that doesn't scale. We need more people to step up to and be involved in these different sub-projects to help bear the load, right? And not only that, but it's a great way to like learn about the system, to learn about the community, to learn about how things function. Because without help from the community, things won't last. This is something that we all kind of share together. And in order for us to actually lift all boats, a rising tide lifts all ships, in order for you to do that, you need to step up and contribute, right? Like, we need you. We need the community to help us make this better. Last but not least, like, we need to sort of streamline our process and processes that we have inside of our system. Right now, we're refining it. We're a step better. We have KEPs now. We actually have a unified way that we discuss things. But it's not, there's always ways to improve. If you're a DevOps style mindset, or if you're just an engineer in general, it's always about optimizing, right? And so if we can reduce the friction, make it as turnkey and as simple to do this as possible, to build up automation around proposal process, to build up automation around how we get reviews in place, that is always helpful work, right? And shout out to Nikita, because she does a lot of that stuff and helps grease the wheels. So as I mentioned before, there's all these different areas that you can help contribute, both on SIG architecture and across the project. If you are interested in SIG architecture specific things, there's Slack channels, there's mailing lists. You can go to the community website, and there's a separate page that lists down all of the details that exist there. All the sub-projects have their meeting notes inside there too as well. So if you want to attend, I highly recommend just taking a look at the project board, see what's interesting. Go to a Zoom call, and stand up and say like, hey, I'm kind of interested in helping out. Is there anything I could work on here? And I guarantee you no one's going to say no to you. There's more work than there are people. So if you are interested in helping out and wanting to contribute, feel free to take a look at those project boards, reach out in SIG architecture on the Slack channel or the mailing list, and just speak up and attend the meetings. With that, thank you. We have a couple more minutes for questions if anyone else has any questions. Just raise your hand. Okay.
For the KEPs in general, the one thing that we found actually this week was if you've submitted a KEP and then someone just has a question afterwards, the only way around that for them to get the question out there without posting the mail list or something is opening a PR and then asking like, in specific line, what do you mean by X or Y? Do you know any way around that, or has this come up before?
So I don't know if you were there when I think it was Alice asked the question earlier. But if you submit a KEP, I highly recommend working with a chair or a TL. They will help guide you through the process and also loop in the people that need to be involved. So like, for example, in SIG cluster lifecycle, if you submit a KEP for something like kubeadm, which I'm a sub-project owner for, I will make sure that all the people there are involved inside of that. It's usually on the responsibility of the chairs and the TLs to make sure that they grease the wheels, that they get eyeballs on it. Because if you just submit a KEP blindly, there's no guarantee, like it's analogous to submitting a PR to Kubernetes. There's no guarantee that it'll be triaged within a reasonable time frame and that you will actually get the correct people to work on it. So Kubernetes is essentially a SIG-tatorship, right? So work within a SIG to make sure that you actually get the eyeballs that you need to help get that rolling.
This is for like the existing KEP almost, like the V1 Ingress one. We had the SIGNet meeting the other day, and then there were some more questions that people raised on it, along with some enhancements that we're putting in.
Yeah.
It's kind of like an in-between phase.
So if there's contention, which can exist too, like Ingress, that's a really thorny topic, right? Like Ingress has not been like fully flushed out since like the initial inception of it, right? And I know Dave Cheney has very strong opinions on what Ingress should be and should not be. You'd have to work with like Hawkins to get that into a happy state, because he's got long-standing opinions that exist there too as well. So he's the chair for SIG networking. I'm not. Architecture usually won't trump the chair. Architecture goes to be the administrator for last issues where you can't resolve it with the chair. Are there any other last questions? All right. Thank you, everybody.
Thank you.